Okay, let's go ahead and solve this. So again, here's what we were given. Some containers strung up by these cables, and we notice that F sub B is horizontal, but F sub A has a force of 200 newtons at a 60-degree angle like that. And what we want to know is what is force B and what is the mass of this barrel right here. So let's go ahead and do this. We're asking for a force, and so what we need to do is use the procedure for this. And here's where all the forces come together, that little spot right there. So what I'm going to do is draw a free body diagram of that spot. So pulling down on it is the weight, and then pulling up and to the left at a 60-degree angle is FA, and that's 200 newtons. And then FB, the tension in that is pulling to the right. Okay, so, and those are all the forces that are acting. So now we define our axis system. This will be our X direction, and this will be our Y direction. No need to tilt the axis here. Then we're going to sum the forces in the X direction will equal MA in the X direction. But we notice this problem, there's no acceleration in this problem. It's a static problem. So the acceleration will be 0. And in the X direction, oh, I forgot, we have to break up FA into its components. So this will be FA, since this is the adjacent, this is 60 degrees, this will be FA cosine 60, and this will be FA sine 60 degrees, this vertical component right here. And so in the X direction, I've got F sub B, pulling it to the right, minus FA cosine 60 equals, and those are the only two forces in the X direction, so they equal MA, but since the acceleration is 0, these are equal to 0. And this lets me solve for FB directly. FA cosine 60, so let's plug in the numbers, 200 newtons times the cosine of 60 degrees. Well, the cosine of 60 is 1/2, right? So 1/2 times 200 is 100. 100 newtons. Everybody agree with that? Okay. If you got that on your own, you're in good shape. At least for this, Well, let's zoom out a little bit, make some more room. Now we need to find the mass. Well, the mass is in the weight, and that's in the Y direction. So let's sum the forces in the Y direction equals MA in the Y direction. And I look in the Y direction, and I've got FA sine 60 equals, oh, I'm sorry, not equals. This is what's pulling up. This is the only upward force, and then we have this downward force. And that's equal to 0. And this allows me to solve for M. I'm going to add it to the other side, and then, so let's just do this. mg equals, we'll put this on the other side and then just switch the order. Now just divide by g. And let's go ahead and plug in the numbers just to save a little time. And divide by 9.8 newtons per kilogram. And when we go through the arithmetic, what do we get for our mass? 17.67, or how about just 17.7 kilograms? Let's see. Sine of 60 is 0.8, almost 0.9, so then you divide that. But yeah, that looks reasonable to me. Does everybody agree with that arithmetic? Did you go through it? Okay, so this is one type of problem I want you to be able to solve on the exam. I might give you the mass and ask you to find the forces, FA and FB, or I might give you all the forces in the mass and ask you to find the angle, theta, right here. But it's going to be a problem very similar to that. It might be something where these two are coming off at equal angles. And but there will be a hanging sign kind of problem on the test next week. Okay? That is all.